Alrighty, so I don't really do voice recordings very often, probably the first one I've done here, I think. But basically, this is what I've been working on for the past, I don't know, month or two. Essentially, what I'm doing is I'm working on a modular vehicle system for VRChat, which means you have different modules, ones that produce lift, ones that produce drag, ones that produce thrust, wheels, buoyancy for water, and with having this fully modular system, you're able to create any kind of vehicle that you want, from planes to cars to zeppelins or even sailboats, and similar things like that, helicopters as well. So currently, it's still very early on. But right now, what I have at the moment are a few modules. So if I go to here we go. So currently we have, let's start with the physics modules. First off, we have the lift module. This module, essentially what it does, I'll go to one of the planes to show you how it works. Basically, first off we have the wing module. This module will generate lift and drag based upon this drag curve, which basically says that depending on the angle relative to the wing, depending on the direction in which the plane is moving, it will create that much lift. Which, the reason why we have this and not calculate this in real time is that if we do calculate this in real time, that is extremely difficult and very, very expensive. So instead we just essentially we pre-compute it and put it into a graph. So it runs faster, and yeah, it's also more accurate too. And here we also put in the lift origin. The lift origin is the point in which the lift will be produced from. So if I go here, this is the point in which the lift will be produced from, or where it will be calculated from. We also put in the area of the wing as well, the density of the fluid, and the up vector. The up vector just states which direction is up. So for this, the y would be up. And then the force origin, this just says where the force should be applied, which we just want to be applied in the wing, so we just put the wing right here. External forces and thrust forces, this is for external forces like wind. Thrust forces is for calculating the lift produced by a propeller going over the surface of the wing, and then depending on the velocity of the air that's being produced and the air that is moving outside, it will change the amount of lift and the way that the wing acts depending on that. Yeah. The other module that we have right now is the thrust module. So the thrust module is pretty similar to the lift module, however, it's just been designed just to work for propellers much more efficiently, because with propellers, they have to spin extremely fast. And since they spin so fast, the way how I normally would calculate the lift and drag for a wing does not work here and ends up breaking after a certain speed. So I have to do different calculations. But essentially it's very similar. You have your lift and drag curve. The prop origin states, excuse me, states the origin in which basically the prop origin is just the roots of the propeller, so it knows what part of the propeller should spin. Then we have the blade origin. The blade origin is basically essentially it just tells it that, oh, I'm going to be sampling this point, this is where I'm going to be calculating the lift essentially, and that would be attached to the propeller. Since all this has been calculated in real time, the angle of the propeller actually matters and how much lift it's produced as well, which is pretty cool. Next after that we have the blade number. Blade reference, that's just used for calculating to make sure that it just makes calculations easy. It's basically the blade origin, except it doesn't rotate or move. The blade number is just how many blades the propeller has. Currently with this module, the reason why we have that is that we're not actually calculating the lift for each individual propeller blade. We're doing it for one propeller, and then we're multiplying it by the number of propellers to make it kind of act as if there are multiple. In the future, I'm going to have a module called a rotor module, which will be used for helicopters and such, which will actually calculate the individual forces on each propeller blade. As with helicopters, the pitch of the blade changes throughout the revolutions, which is how they're able to pitch, yaw, roll, and do all of that. Next, we have the blade area, which is just the area of the blade. Next is the radius, or basically the point from here to here, so it knows how long the blade is. That's just there for doing the calculations, because like when it starts spinning so fast, I have to start calculating the velocity from the circumference of the propeller, which is why I need the blade radius. Blade mass, that's just basically the weight of the blade. That doesn't matter too much right now, as I don't quite have this fully implemented properly, but the blade will also react to forces like wind, which will make it spin, and things like that, which even allows us to make a gyrocopter, which is pretty cool. Blade velocity multiplier. This is not really used anymore. This was just so that you could essentially multiply the velocity Right, the blade force, before we get to that. Blade force, that's just the amount of force that's being applied to the propeller to make it spin. The blade velocity multiplier. This isn't really used at all anymore. It's kind of for debugging. This is just used for, basically it's just used for, what was it again? Right, it's just making it so that the propeller doesn't have to spin as fast to produce lift. Next one, external, we don't worry about this. Fluid density, again, the density of the fluid up vector. This is the up vector of the prop, so for this it'd be the z direction, and then the forward vector is basically the forward direction in which the blade is spinning. So that would be this way, which would be negative x. And then the lift module has this as well as the center of mass of the vehicle, so it knows how to apply the force. It's right here as well, I forgot to mention that. And then the throttle, this is more temporary. Again, a lot of this is a little bit early, but currently this just gets the value from one of the other modules, so it knows how fast the propeller should be spinning based upon that. Next, we have the physics module. The physics module is kind of cool, actually. The physics module is kind of what makes this whole thing modular. Essentially, the physics module, you drag and drop all the other modules on the plane directly into the physics module. So just press on the plus button, and you drag and drop the scripts right into here. And then it'll automatically grab the forces and the rotational forces and then apply it on the vehicle. And it'll actually calculate depending on the position of each force and all that and the center of mass and everything like that. It'll automatically calculate all the forces being applied to the vehicle, which kind of makes this whole modular vehicle. So you have a plane that has wheels here. I don't have a wheel module yet, but I'll be doing that in the future. But yeah, we'll have wheel modules, so you just drag and drop them in here. But currently we just have the thrust module and the lift module, and those get plugged into here, and then it'll calculate all that. We also have this section, so you also need to put in the rigid body and the constant force. The rigid body, I forgot, why do we need this here? I believe, hold up. Here we go. See, why is a rigid body needed? Okay, right. So the rigid body is needed because we'd be able to set the center of mass of the vehicle as well, which is pretty important. So we know kind of the pivot point at which the plane needs to rotate about. Then we also have the constant force. This is the part that actually just applies the forces to the vehicle, so I need to have constant forces in there. Next we have the vehicle main comm and the vehicle comm. I'm not going to get too much into this, as I don't want to spend too much time explaining things. But basically this is the center of mass of the vehicle, and then we set the mass of the vehicle here. We also have external mass too, which is pretty cool. Basically what we do is that the seat modules actually take into account the player's mass, and whenever somebody hops in a seat or exits a seat, their mass will basically be added to the total plane's mass, making it heavier, and it'll also offset the center of gravity, changing how the plane flies, and its characteristics in terms of its top speed and whatever, all that stuff. So it's all actually calculated in real time, which is pretty cool. The next modules, I think I'll do the modules for the levers and the yoke. So this is pretty cool. So again, since this is modular, so go back to the stick root. Here we go. So this is for the yoke modules. This is pretty cool. The yoke module, basically, first off, you assign the vehicle origin, just the origin of the vehicle, or just the vehicle itself, so it knows the rotation of that. Stick root, that's just basically the very root of the joystick, so for that, that would just be, well, this right here. Then you have the stick itself, which is a stick. And then the handle is the handle, which is this part up here that just rotates by itself. And then you have the grab position, which is the position in which the player's hand needs to be in order to grab it. And then below that you have the grab distance, or how far away the player's hand needs to be from grabbing it. So again, in VR, you'd actually physically grab this as well. So you grab it with your hand, and then you'd actually move your hand left and right, up, down, and even twist as well for controlling the different control surfaces. And then here you set the limits of the angles, so how far the joystick could rotate in all directions. Angle offset, I'm not going to explain too much in that. Up vector, the up vector in which this is mainly just used for rotating the handle. The up vector, the up direction in which the handle is facing, and then the right vector, so the vector to the right of the handle. Yeah, the handle, so this is basically just used for calculating the twisting motion of the stick. So basically this motion right here, so it knows that that is correct. After that, we have the keyboard controls. So basically just input what keys you want to activate what, essentially. So he knows that, so X, W, S, E, Q, A, and D. So W would be making the stick rotate forward like this, S making it go backwards, E would rotate it like this, Q would rotate it like that, and then let's see here, A and D, A would go this direction and D would go this direction. And then this is basically how fast the joystick moves to those different angles when you're in desktop. This is for haptic feedback, so when you grab the stick, it will essentially vibrate your controller, and then if you're highlighted, basically that means you're close enough to grab it. So it'll do a little like slight vibration compared to a much stronger vibration. And then animator parameters. Basically you drag and drop your animation controller for your plane in here, and you assign the parameters for the X, Y, and Z, and you also have parameters for grabbing and highlighting in case you want to play animations if that occurs. So I go to the plane and I head to his animation controller. You can see that I have the pitch, roll, yaw, and then prop. I'll explain that one in a bit. But basically, so if I go into pitch, you can see that if I go into here, drag and drop the plane into here, you can see that when this changes, it changes the pitch of the elevator. So that's basically just controlling the pitching up and down movement of the plane. So essentially this, where are you? This drives an animation. So basically makes this even more kind of customizable what you want to do. So you don't have to have it drive, you don't have to actually have it drive the control surfaces of the plane. You can have it really drive anything like wheels turning or I don't know, some like massive robotic arm. It could really be anything you want. Yeah. The next module that we have right now, or a control module, I guess you could call it, is the throttle module. This one's still somewhat a work in progress, kind of ish. It is pretty finalized. It's pretty good. I might go back and redo some parts, but basically this is just for doing levers and such, or pushies and such. It's very similar to the other one. You have the lever handle position, which is this right here, just the basically the game object in which the handle is attached to. You just put in its default position. The hand origin, this is again used for doing some weird stuff that I need to do just to make the calculations easier. This is just another game object, and they put in the default position of this, or the local position of it. The lever vector, this basically is in the direction in which the lever will move. So for 1 on the z-axis, I'd make it move forward. If it's negative, it would then move backwards. If it was positive, if it's like +1, and the y, then make it move up, etc., etc. And then this is the basically lever displacement. That's how far the lever is able to move before it will stop. The grab position is again just the position in which your hand needs to be in order to grab it. And then if your hand is close enough, so 0.075 meters, then you'll be able to grab it. Keyboard controls, left shift moves it forward. Left control moves it backwards. Key sensitivity is basically how fast the stick moves or the lever moves forward and backwards based upon that. Haptic feedback, exact same thing as before. And then animation parameters, does the exact same thing as the other one as well. You have your parameter, lever grabbed, all that. Yeah. Next we have a few more modules such as the seat module. Let's get into that. The seat module is not quite yet done. But where are you? I have a special slot. There we go. So the seat module. This is a bit difficult, more difficult to explain, but basically the station is just the station of the VRChat, just so you set to immobilize for vehicles, disable station exit. Physics module, basically whenever someone hops in the seat, essentially the reason why I have the physics module here is that whenever somebody hops in the seat, we want it to update the player's mass, or basically add a mass to it, and add a mass to the vehicle, so it updates that, which is why we have player mass and the mass transform. The player mass is the mass of the player, and then the mass transform is basically the position in which that mass is applied. Next we have transfer objects, basically to add more or less. This is mainly used for syncing and such. I'll go over to the sync script in a second. But basically, for the sync, so for the transfer objects, so whoever hops in the seat, it will transfer that object to them as their owner. So for example, the reason why we're transferring this to the owner, or making the owner of this plane of the person who's sitting here, so if they're the pilots, we want them to be the owner of the plane, which then leads into the sync script, which I will get into a second. But basically, if you want to have any scripts in which the pilot is the owner of, you just drag and drop them right into here. Is seated, this is just used for essentially saying that, oh, if the player is seated, then let them have access to these controls. So basically, is seated, just drag and drop all your different controls in here, and it'll just basically make sure that they'll only be able to access the controls if they're seated in the seat. And yeah, that's the seat module. I also need to add in an automatic eye height, so basically when you sit down and make sure that your eye height is always in the right spot, because VRChat seats are a bit of a butt, and instead of making you like sit, I don't know, actually in the seat will like either move you forward or backwards or up or down and all sorts of things. It's a bit annoying. But yeah. And then next right now we have is the sync module. The sync module is still kind of work in progress, but basically you put in the game object of the vehicle, the rigid body, and then also the physics rot. The physics root is basically just the game object which has all the different physics stuff in it. And something to notice that in the physics sync, in the vehicle sync, essentially the reason why I have the physics game object here is that it will only turn it on if you are the owner of the vehicle. So if you're not the owner, it will not do all the physics calculations it needs to do for all different surfaces. It'll only do that for the one who is flying, just to make things more optimized. And then set owner, this basically sets it like, essentially just says that, oh, if you're sitting in the seat and you're the owner, basically this says that if you're sitting in the seat and you're the owner of the plane, then you can have access to these. There's another variable in here that's called set owner that needs to be true in order to have access to these. Basically that if it's true and it knows you're the owner and you're seated, then it will let you have access to these. Update interval is basically how often the script updates. Smoothing velocity, that smooths out the velocity. So instead of setting over the velocity, I calculate it based upon the current position, the previous position that was sent. However, it's a bit unreliable for some reason. I'm not quite sure why. It just is. So I have to smooth out a little bit, make it a bit better. Smoothing time, that just basically, this again makes things a bit, technically I shouldn't need to do this, but this just smooths out the amount of time between updates. It helps. I feel like this shouldn't be here, but it helps, so I have it here. Acceleration influence, this basically says acceleration influence either 0 or 1. I should make this a slider, same with some other things. But basic acceleration influence will say, it'll also try to predict the acceleration as well of the vehicle, depending on the current velocity and the last velocity to more correctly calculate where it thinks the plane is going to be based upon the amount of ping and the update time, or the since it only updates every 0.2 seconds, it has to basically calculate 0.2 seconds in the future plus ping as of where the plane should be. And this also will basically, this will just say how much should acceleration influence that calculation. Smoothing target time, this is just used for essentially, I want to also calculate the velocity for the rotating of the plane as well. However, I'm not doing that quite yet because I looked into the calculations of that and that was a bit scary. So I'm holding off on that for now. So I'm just basically slurping in between the rotation of the plane that's being sent over. Yeah, so this just says how fast it should basically interpolate between the different rotational vectors that are or rotational quaternions that are being sent. Yeah, that's kind of the whole system. I guess I'll just show you it working now. But yeah, all right. It's really cool because again, it's fully modular to do what, I don't know, it's cool. I'm happy with it so far. All right, so here we are. So you hop in, we have our control for the throttle. Right, I forgot to explain what this is. Controls the angle of the blades in the front. You can see that happening ever so slightly. So you could actually control mid-flight the performance of a propeller, or even have reverse thrust by basically changing the angle of the propeller, which is pretty cool. But yeah, and we also have the joystick as well. So we have EQ. There are some bugs. I don't know why that happens exactly, but I'll figure it out and fix that. But for some reason, if you're stationary and you start moving your stick, this plane will sometimes jump around a little bit. I don't know why, but yeah, EQ moves it like that. AD, all that moves around. And we do shift for increasing the throttle. And there we go. And again, if you're in VR, you'd actually be using your hands to do all this, which is pretty cool. But yeah, you can see how all the control surfaces are moving. And again, it's actually the movement of the control surfaces that are affecting the rotation and the plane and such, which is pretty cool. It's not just like some force being applied to the plane. It's actually the rotation, the area of the control surfaces and everything. I don't know, the rotation of everything. The rotation of the control surfaces is deflecting the air, which is causing the plane to pitch, rotate, yaw, and do all that fun stuff. But yeah, it's pretty cool. I don't know, I'm really happy with it. And it works really quite well. It's a lot of fun in VR as well. It's still very early on, so there's still a lot of things I need to fix. an update. But yeah, I don't know. I'm quite happy with it. It's coming to lane. We make use of our reverse thrust. Oh, actually, this is a bit too tight, so I'm gonna go around again. But yeah, I don't know. It works really, really well. And this is kind of cool too. When you're flying at really low speeds with this plane, when you're flying at very low speeds with this plane, the control surfaces don't produce as much lift or force, so you actually end up turning much slowly and have a lot less control over your plane, which is pretty cool. So I'm gonna just turn around here. I'm gonna slow down a little bit. I'm gonna use the reverse thrust. Okay, full thrust. There we go. Okay, cool. Alright, but yeah, reverse thrust is fun because you do a lot of funky shenanigans. Like, for example, you do like a cobra maneuver in the air. Oh, right, something else to talk about too. I forgot. See here. So, if we go into here, right. So I kind of briefly talked about the mass system right here, but this is pretty cool. Basically, the masses, this is pretty modular. So you can actually have it where it takes into account like other masses, like the weight of fuel and how that changes, how it changes the CG over time, and also maybe payloads that you're carrying is too. You just basically drag and drop the scripts in here for the different, like your fuel weight and also the payload weight and things like that. It's pretty cool. Essentially, like for this, where are you? Here we go. So for the physics module, essentially when you're updating the mass, it gets the just gets the mass itself and the position of the mass, and then from there it recalculates the center of mass and then applies that to the rigid body. Yeah, so you do some cool things with that. Yeah, something. I think that's kind of all I have to say. Yeah, I'll put a little video. I'll a little tiny little video of it working in VR too and such. But yeah, I don't know. That's this. Yeah. And thank you for watching. Yeah, thumbs up. I hope you enjoyed. Okay, here's the video. I'm actually going to record a little voiceover for this too because there are some things I didn't quite talk about. But yeah, you can kind of see there is a little bug right here where if you move the stick left and right, it'll kind of jink out a little bit like I showed before. But yeah, I see I'm going to use a reverse thrust up here to kind of get out of this situation and then take off because I can't really pivot in the plane while on the ground very well. But basically, so another thing I didn't quite talk about in Unity, while showing how the system works and such, is that I want to add in a damage system as well, where each individual part of the vehicle can be damaged, such as wings or wheels or whatever it may be, and actually affect the characteristics of how, like say for example, the plane flies. So like if one wing is shot at and gets heavily destroyed, it'll produce less lift and will kind of affect the plane and how it flies, maybe making it roll to the left or right depending on what part of the wing, depending on whether the left or right wing has been damaged. Yeah. Yeah, I know. That's kind of all I have to say regarding that. But yeah, I don't know. It's cool. And like you see, like, I don't know, in VR it's a lot of fun to use, again, because all the controls are very physical. I don't know. I enjoy it quite a bit. It's pretty cool. But yeah, I hope you enjoy the rest of this little flying.